As you can see, our next lecturer is Dr. Nadira Degembayeva. I hope I pronounced that correctly. She is Associate Professor and Head of Department of Agrarian and Technological Disciplines at Naren State University at Kyrgyzstan. Her areas of expertise are hydraulic engineering, construction and river building, hydropower plant, hydraulic engineering, etc. The lecture is very interesting, named floodplain areas and floodplain areas and flood forecasting. Sorry. And I can't wait to hear that, because here in Bosnia we had a big impact of floods in 2014 with very negative impacts on local citizenship. Thank you very much. And please, Dr. Nadira, can you deliver us your lecture? Just stop sharing, sorry.
Hello, everyone. Hello, everyone. Do you hear me?
Yes, we can.
Yeah. I will now share my presentation. Can you see my presentation?
We can. Can you just press F5?
Yeah, please.
Okay, thank you.
Okay, good. Hello, everyone. Hello, dear participants. Dr. Sanjay and also Maya, thanks for presenting me. I am Nadira Degembayeva from Naren State University. My today's topic is floodplain areas and forecasting. And here you can see my main contents this presentation. This river floodplain, formation of the floodplains, elements and structures of these areas, and also floodplain ecosystem, flood and forecasting, and the last one is a case study of Naren River in Kyrgyzstan. So here we took two examples as depict the floodplain area. These areas with meander and dreaded structures. It's Amazon and Mississippi rivers. These rivers have a naturally ongoing process of floodplain areas. But here we can look the formation of the floodplains, these rivers and their tributaries from channel banks as they cut into the earth in their flow downstream. These banks from over time and became established at a height that confines the river its channel. And when stream flow increases to the point where its elevation exceeds over bankful stage, then part of the water of the river goes onto the floodplain areas. We're here to note about the floodplain. These areas lowers covered by vegetation, and it's partly or completely flooded during the flood events. The reason of the floodplain formation is a result of the erosion accumulating activity of the river flow. And floodplains are low-lying areas adjacent to river that are formed by sediment and deposited by river. So floodplain areas are very important, is essential for the healthy function of the river system. We can see here two conditions of the floodplain areas. A river experiences flood and of various magnitudes through the time. Major flood events, it is deeper flow on the floodplain, produce higher velocities that can cause considerable soil erosion and sediment transportation. In this figures, we can see low flow channel and also high flow channel. This high flow channel is last one have a bankable stage. This is the elevation of the top of the stream bank, where water begins to overflow onto the floodplain. It's the bankable stage. And if you look at the profile or characteristics of the floodplain areas, this is the we can divide some main structures here, main river and also floodway, which inundated zone when floodplain events occur, and also flood fringe. Now we are flowing in second topic, subtopic. This is a formation of the floodplain. Here we the discharge is the most effective at doing the work effective at work, and that maintains the channel morphological characteristics. The largest stream flow discharge have occurred historically in a channel process, and the greatest power to form of the channel and transport the most sediment. And however, this level occur infrequently, but in many river system flows onto the floodplain every 1 or 2 years. To power of these infrequent stream flow events can move the large partial accumulated in the channel that would be moved in more frequent events. Over time, the river in the upper erosion zone lowers its base elevation and new floodplain develops. So also key points about the formation of floodplain. This river are constantly modify the channel and also surrounding relief. As a result of the potential energy as well as its kinetic energy, the river cuts vertically into a channel, and this creates initially a deepened channel and as a result of hydraulic action and abrasion. Due to the surface runoff, soil creep and other mass movements, the valley side becomes more gentle. Every river flies own valley. About that, here we illustrated the valley profile. We can this valley profile divide this for 3 main zones. This erosion zone, tributaries, transition zone, which call it mainstream, and also deposition zone, which all this sediment which transported up upper zones deposit here, and we call this zone mouth. The question how a river works, we can say streams meander as the hydraulic gradient is reduced, then they move laterally through the valley floor by eroding one bank and depositing other side, opposite side, and streams can migrate laterally within the floodplain as a result of both flood events and also natural channel forming process. Over time, new sections of channel are formed and other sections of the original channel abandoned. This is how most valleys are formed. Here, in addition, we can look at the elements and structures of the floodplain areas. These structures, we can see all these 3 zones which we divided before. Then after this main structures, we can also see other structures of the floodplain. This is called reefs, and slopes or over time, as meander becomes established, the pools deepens, and sometimes regular shallow sections. About it, we can see various form of the floodplain areas. This here also we can see the bigger structures, which call it islands. And the gravel deposition mainly in this formatted island, mainly populated by vegetation and format larger structures. In the rivers, we can see such structures, islands which covered by vegetation, and also divided in other terraces, gravel bars, pioneer post forests or post pioneer forests. The cross section of the river is floodplain area. We can also divide main channel, island, and also natural levee, or all these floodplain which formatted. And we are moving other subtopic. This is floodplain ecosystems. According to the Millennium Ecosystem Assessment, definition of the ecosystem services for the floodplain areas also provide some natural resources and contribute to human well-being. We all know about the ecosystem service, which divided provisioning, regulating, cultural, and supporting. For a floodplain ecosystem, for example, we can say as a provisioning service, they obtain it as water, timber pool, or non-timber pool forest products. As a regulating service, we can say here air or water purification, erosion prevention, water storage, and also the main for us, it's climate stabilization. As a cultural service, we can see here spiritual connection with nature, and also heritage of the place or recreation places which people use these areas. Supporting services is foundation building blocks, ecosystem which include nutrient cycling and pollination also. This slide shows us the linkage between this service with well-being, human well-being, and we can see we can have a lot of goods or social relations for our livelihood. Key points of the floodplain ecosystem. I would like to note the concepts of ecosystem service included in scientific studies and manager strategies as a social process to bring the finding of science to be on the needs of decision makers, and also an analysis of the natural ecosystem with its structures and processes, investigate how this contributes to human well-being as ecosystem services, and tries to estimate people benefits in terms of the monetary valuation. To assess the benefits of the floodplain ecosystem, we need to conduct ecosystem service research. In this research participated local people, also government, private sector, and civil society. And the results of this research provide us first insight into the socio-economic background of the ecosystem service of the floodplain areas. To analyze the assessment of the ecosystem service, we can use conceptual framework of the ecosystem service cascade, and this helps to analyze natural ecosystems with their structures and also processes, how they contribute to human well-being as ecosystem service, and attempts to measure the benefits and also in part of the monetary value, and we can also estimate anthropogenic pressure. And here we can limit the pressures. We need to have solution about that via policy actions, and this structure will be useful for analyzing floodplain ecosystems. Now I'm moving another subtopic is floodplain and forecasting. Floodplain areas are often flooded during floods, as mentioned before, and therefore we need to study changes in the hydrologic regime. The factors that determine the magnitude of the stream flow, volume, or peak flow can be separated into that are fixed and those varies with time. Frequency curves for engaged watershed can be approximated by performing regional analysis or modeling the stream flow of the river. And for this, we need data, long-term data, precipitation and temperature data. Here we can see hydraulic modeling flow chart, and this flow chart shows to prepare digital elevation model. We need to extract land use and soil characteristics of the watershed. Also, we need to define a flow direction, flow accumulation, grade process, and watershed delineation, and give us a digital elevation model. Determining of the flow accumulation and also flow direction, and give us to delineate the watershed, the flow direction and flow accumulation grids needs to be built and the process is in a correct order way. And with the correct tools, we can appropriate for the study area and digital elevation model. We will define the PowerPoint, define on the PowerPoint and we before used the model structure WASIM. For example, I put it here, and we can see in this structure of the model, we can input methodology, precipitation data, land use, and all we need, we can input this data. And as outcomes, we will have, if we follow these methods, the first GIS spatial data processing and analyze the outcomes of hydrological modeling by delineating watershed and extract land use and soil classification of the watershed, land cover and soil data preparation and processing, input data into hydrologic model and run the model, and then we get the sensitivity of the hydrologic model with different scenarios. We can build different scenarios, develop different scenarios of the land use change to the river discharge. Now I am going to last subtopic. This was case study of the Naren River in Kyrgyzstan. Before start, I would like to give some geographic information. Kyrgyzstan is located in Central Asia. We are bordered by Uzbekistan, Kazakhstan, Tajikistan, and also China. Here you can see some geographical information about the elevation, population, and also area of the country. This study supported by Volkswagen Foundation, and we can see here our main partners. And now I'm start to explain our study work. To study Naryn River, we selected two study areas, which one is located far away from the floodplain areas. Second one located near the floodplain area. These settlements located in the Naryn province, and the name of this province connected with the big river. This river is the right tributary of the Sirdarya in Central Asia. The Naryn River catchment starts from northern and central region of the Tian Shan, and the source of the Naryn River begins from two rivers, Big and Small Naryn, and also for formation on this river contribute the glaciers of the Aksherat mountain range. And floodplain vegetation species include poplar, willow, and as shrubs, honeysuck, sea buckthorn, spirea, tamarix, rosa, and oleaster. Here, overview of the floodplain areas. These floodplain areas we can see in several seasons. The climate condition of the Naryn River watershed are characterized by a continental climate and cold and long winter and short summer. So, according to the Naryn Meteorological Station, the average annual temperature for 1886 to 2005, it's about 2.7 degrees Celsius. The coldest month is January and warmest is July. For the trend of the hydrologies, here we can see the intensity of the spring flood was observed in June, and this flooding time lasts until September. Here we can see the trend of the temperature, and this shows increased trend, and the precipitation trend shows decreasing. According to the data of the measurement of the flow rate, we use Naryn State meteorological station, and we can see here daily discharge of the river from 1988 to 2017. In this hydrograph, we can see between 1995 and 2003, we have several larger floods. Then followed the calm period, and after we can see here last one, the major flood events which took 2016. As a main factor for the hydrological regime, we analyzed the average, maximum, and minimum summer water discharge for each year, and also we analyzed the average groundwater level. This groundwater rises when water level of the river is rising also. The discharge trend of the Naryn River shows us the trend which has increasing. We can see in this right side the main flood events occurs June and July months. Mapping of the extreme flood events, inundation patterns. It helps us to understand the floodplain structures. About that, we here determine the water level, which occurs flood event in June 2016. Now, about the floodplain areas of the Naran River in Kyrgyzstan, its areas for Kyrgyzstan are important during floods to reduce peak of discharge, because after this river in the downstream, there are located a lot of settlements. About that, it's very important. In this photos, you can see how is last floodplain damaged the bridge. And also this leads some anthropogenic pressure as a grazing. Local people use these places as a pasture, and also local people collected firewood, forest berries, and so this result of this pressure you can see here. And also deforestation of the floodplain forest near the village reduces coastal resilience and leads to greater vulnerability to coastal erosion. Here I would like to start on the structure of the geomorphologic units. We can see in this Naran River floodplains several forms of the structures. It's gravel bars, formatted island, and terraces and high terraces which are disconnected with floodplain. These terraces is old terraces, so nowadays is disconnected. And mainly these coastal zones populated by vegetation. Here we try to identify the places of the floodplain areas where erosion and accretion occurs. We use a method proposed by Kumi. The erosion areas of the bank movement rates are plotted as function of distance along the river banks. About that, we divided these two sites in this sub-reaches. The change of the bank location for each time we are indicated in the table. This one here we can show 5-time series. The average bank accretion of about 0.6 meter and average erosion is about 1 meter per year. Also, we can see here a profile across of the floodplain areas. These areas have structures, main floodplain areas, and also main flood channel and post-pioneer forests. Ecosystem service demand of people living of the Naran River. Here illustrated our results of the questionnaire. These local people use this area as a recreational, as a pasture, as provision of pastoral land, and provision of fallow soil. And also they collecting wood. We analyze by using this conceptual framework, which mentioned before, and this ecosystem cascade give us main analysis of ecosystem service. Here, which goods they benefits from floodplain areas, and also monetary value of this from these goods, and anthropogenic pressure. Is mainly this pressure overgrazing, wood cutting, and this much or mismatch of the regeneration and research usage. And how we can stop? We can put here as a privacy action as a control through pasture committee or local foresters. And this helps to analyze the condition of the ecosystem service. After definition of this cascade, we also mapped of ecosystem service of floodplain area, which divided water surface, gravel, ground, and grass water, and bushes, and also trees. This ecological zoning map essential for the sustainable management of the natural resources and reflects of ecosystem service and also their components. Mapping riparian forests helps to plan and effectively manage the activities of Department of the Forestry and local government to improve soil and water protection functions. Overall, after these studies, we come some recommendations for the local governments. It's develop of a rule for regulation of this forest use and organizing of a local tree nursery. Also, appointment of the reasonable person controlling the forest use. The community will decide who will controlling, and this also recommendations comes with community when we conduct some workshops, and also rotation of the areas in the forest use because of how you see before there is takes place some deforestation. And the consequences of these anthropogenic impacts are not only flood risk or bank erosion. Also here research, natural research regeneration. This regeneration and seed establishment of woody floodplain species are affected by grazing. However, conservation of biodiversity and maintenance of forest ecosystem function are significant in this era of climate change in mitigating climate change consequences. Now I am done with my presentation. Thank you for your attention.
Thank you very much, Dr. Nadira. This was very interesting and useful presentation of your lecture. We can all use your conclusion for Naren River floodplain because they are almost the same for the all river basins. It is necessary to reestablish our ecosystems and work harder to develop adequate models for flood forecasting.